Right. Welcome to Wise Up on Air. My name is Damian Kaspauer. I'm a software product manager here at Audiokinetic. How about that new countdown? Huge shout out to Lauren on the marketing department for putting that together, superimposed with a bunch of great footage from past Wise Up on Airs. And if you're not familiar with the series, we like to go hands-on with developers out there using Wise in creative ways to reach for these incredible interactions with sound using Wise. And today we're excited to dig into the beta 3 release of Wwise 2025.1. This will be this year's release, and we're just nearing the end of the summer of beta. So I'm going to dig into that, and we're also going to go hands-on with some of the new features with senior software developer David Crooks. So stick around for that, but let's go. So this one we're going to talk first about what's in the Wwise Beta 3. And if you've been following along at all, we've been having a great time this summer exposing features of the new release as part of our summer of beta. And it's the 25-year anniversary of Audiokinetic. That's a lot of game audio years out there in the community. So something to celebrate in the community as well. So and if you're in the chat, I hope to hear from you today. Keep us posted with any questions that come up. Good to see you out there. Meanwhile, Beta 3, it has evolved over the course of this summer to include more and more exciting features for you to get your hands on early as part of this beta release. And we've been here all summer doing it, rolling it out, bringing new updates and gathering feedback from folks like you, giving it a try. Here we are at Beta 3. Let's talk about what's in the box across our user experience, spatial audio, 3D audio, and acoustics technologies, integrations, and sound engine. All of it pulling together into a comprehensive workflow with Wwise for interactive audio. And a huge shout out to all of the devs here at Audiokinetic who've been working hard this summer to stabilize and bring this release fully to development pipelines in the fall. Let's kick off with some user experience, talking about the media pool. This is a feature that is new in 25.1 and connects the focused and iterative real-time workflow, our live media transfer and live editing features, with the ability to reach into your project originals folder, as well as your user-defined databases of sounds to either begin or continue content creation in a fully live and connected remote workflow with your game. We also added the similar sound search feature in beta 2 that I'll talk a little bit more about. But meanwhile, we've delivered the media pool as a way for you to really get your hands on the content side of things and make that part of your runtime development workflow. In beta 3, we've added some a feature to the transport that allows you to apply the properties on import. So now when you're auditioning your media pool results, you can apply properties to that audition. So hearing it, louder, softer, higher pitched, lower pitched with filtering. And now you have the option to apply those properties to the render as they are imported to Wwise, either on a per file or per region basis. And as I mentioned, we added a feature in beta 2 called Similar Sound Search, which gives you a unique picture into the sounds that you have in your libraries. This is a collaboration between Sony AI and Audiokinetic. We partnered to bring this AI-powered text-to-audio and audio-to-audio sound effects search tool to the media pool. It's a new way to use audio descriptions to look for sounds based on words and natural language, in addition to finding similar. So that's just selecting an audio file or region and finding sounds that are similar to that. So this bypasses the metadata tagging by looking directly at aspects of your sound libraries and attempting to find things that might be interesting. This is a opt-in feature that you choose to install with a version of Wwise through the launcher. We're giving you what you need to decide whether or not to work with this, depending on what part of your project or workflow you're in. But dig in. We went hands-on with this a couple of weeks ago as part of our beta 2 live stream. We had the folks from Sony AI join Audiokinetic developers Bernard Rodrigue and Etienne Richon, and we had a lot of fun. So dig back in, it's all chaptered up, and you can learn more about how it works. And get signed up, because we've got some focus groups that we're putting together for the media pool and Similar Sound Search. We're always trying to get feedback from the community about how these products are landing in your workflows. And so we'd be great to have you at future focus groups so we can talk more about it in person. On to user interface improvements. If you haven't heard by now, we have done a fair amount of renaming in the Project Explorer hierarchies, merging the interactive music and actor mixer hierarchies as the containers, renaming the actor mixer container to property container. The master mixer hierarchy has been renamed buses, and the master audio bus will now be called the main audio bus when you start a new project or create a new top-level audio bus in your project. So we think these naming changes land squarely in the accessibility side of the world, allowing folks who are new to Wwise to better understand what is encompassed by these hierarchies, and just gives a clearer path to understanding Wwise overall. Oh, and we dropped audio from devices because, of course, they're audio devices. Speaking of what we've been working on, we put out a series recently on YouTube called Rolling for Audio Alchemy with Baldur's Gate 3. These are repurposed excerpts from a live stream that we did with the Baldur's Gate 3 team that go deep into how they handled the object-based mix for Baldur's Gate 3, some of the cool things that they did to support that series in a unique way, as well as some of the ways that they chose to mix across objects as well as sidechaining. So dig in there. But we also have dropped a new multiband meter that takes the place of some of the strategies that they outline in that series, bringing it all together into a single plugin, giving you access to a full band of metering, as well as 4 user-defined bands that can be toggled on and off. Again, this replaces much of the extra work that they were doing in order to get a multi-band like meter solution in place. And it is because of that and because of other conversations that we've had with folks that we've arrived now a year later with a solution that speaks directly to the workflow that they were experiencing, and the folks out there who are reaching for multi-band metering were really asking for. So excited to be here talking about that today as part of 25.1, and it has been in the betas since beta 1. Get your hands on that. We also dropped the parametric EQ graph in beta 1, and that came with 3 bands of adjustable equalization with different curve types and the ability to enable and disable them. But let's fast forward. Beta 2, we increased the number of bands to 8. We went out in the community asking folks, how many bands do you think you need? And while the range we heard was extreme in some cases, we think we landed at a good number for folks out there reaching for extra bands in the parametric EQ. And that brings us up to today, beta 3. We've added dynamics to the parametric EQ, and we're going to talk more about that here in a minute with David. And I'm so excited for you to get your hands on something that is really starting to look and feel like a modern parametric EQ. And at runtime, 4 games, well, it's nice to be here. This is where you're at. Thanks for tuning in. We'll get there in a minute. A few more things to talk about. Integrations. We have aligned our Unity Wise browser with the Unreal Wise browser we put in place back in 2023. So again, making it easier for developers who are maybe going across game engines with their Wise integrations to share the same browser experience when they're working with Wise. We also added dynamic dialogue to the Unreal integration. And if you haven't heard about GIMs in Wise, we have done some deep dives on it in past live streams, some great articles out there. But if you haven't looked into GIMs yet as these small pieces of functionality proven across Unity, Unreal, and also the web, dig in. And we'll have a upcoming Wise Up on Air with Benoit Santar coming up, where we're going to go hands-on with those integration changes for 2025.1. Over in spatial audio, you know this if you've been tuning in. We think about this across a couple of different slices. The first is our acoustics technology, which we've been talking about as part of 25.1 beta 1 and 2, but also 3D audio. And so in beta 3, what we are bringing to this release and to the full release in the fall is an experimental 3D audio recorder for ADM. If you're not familiar with the audio definition model, in 2024, we introduced the ability to add ADM files as a source file in Wise. ADM file encompassing, a position-rich audio format that includes information about pass-through and main mix and audio objects, all of that landing as a source in 24.1. Well, we're closing the loop in 25.1 with the experimental ADM recorder. This gets put on a bus and will record across objects and beds. There's some variables to toggle this on and off. And ultimately, you arrive with an ADM format audio file that will grow to encompass the beds and audio objects that are played during that recording. So if you're into ADM, if you are interested in spatial formats, there's some great tools in the box to allow you to understand that in context of Wwise and continue to find a way to bring greater precision to the positioning of sounds while also staying flexible with the requirements of user-defined configurations and output formats. So dig in, beta 3, 3D audio recorder ADM. And I mentioned acoustics. The folks on the R&D team have been cranking out great features in 25.1. The first one we've been talking a bunch about is the dual shelf filter. This is a new type of filter that arrives at the audio bus, aux bus, and attenuations, allowing for a more natural sounding filtering, especially effective over distance as part of your distance-based filtering. And in early conversations, folks are off to the races with this, moving very quickly towards great sounding experiences, especially in a VR, AR, and just, detailed sonic environment. So dig into the dual shelf filter, as well as a bunch of changes that we've made to your visibility access in the Game Object 3D viewer. We've got a new settings shelf that you can pin settings to for easy access. We've enabled object selection in the viewport, giving you access to object properties in the new object property panel, and just really bringing more to your fingertips as part of that Game Object 3D viewer workflow. And we're going to go deeper into it with Tali Kaklikian and Alan Lee in a future Wwise Up on Air live stream coming October 15th at 2 o'clock Eastern. So put it on your calendar, get subscribed, and get in line. That's going to be a fun one. I always appreciate live streaming with Tali and Alan, and I look forward to landing with them in October. And meanwhile, the sound engine just keeps on ticking. We've made some changes to the way things work, providing great features, stability, and performance. I've been in detail on those at the beta 1 and beta 2, so turn back time and get more information about that and all of our technologies. Check out the What's New. The What's New continues to evolve across beta. We keep adding these features as they fall into place. And so if you haven't circled back to read more about the new dynamics in EQ or other features like the ADM recorder, jump back in. Get the beta, install it through the Audiokinetic launcher, ask questions, report bugs, mail us at openears@Audiokinetic with anything outside of the box, and take the survey. We do take the time to assess and find the right channel to communicate what we learn through the survey to help drive development. So if you have the time, please share your experience. And as I have been doing across each of these betas, stay tuned for feedback communications. We're always trying to bring forward the work that we're doing and the work that is influenced by your feedback and the conversations we have with you. This has been the summer of beta, and we're at the end of it here, nearing the full release, which will happen later this fall. So thanks to folks who have shown up to give the beta a spin. Stand by for launch. We're getting ready for that full release. And when we get there, we got one more thing that I want to talk about, but I'll save it for that Wwise Expo online coming up this fall. So stay tuned. Meanwhile, we're here to talk sidechaining and multi-band dynamics with David Crooks. And so I'd like to welcome David to the live stream. David, how are you doing?
Hi, Damien. Pretty good. Sorry.
Awesome. So great to have you here. Thanks for standing by. And tell us a little bit about your role at Audiokinetic.
Yeah, I'm one of the senior software developers on the core team, which means that we're most responsible for a lot of the runtime operations of the Wwise sound engine, and especially making sure it runs on all the different platforms that we support, as well as making sure make sure it's running well as well,
Yeah.
and also doing a lot of support, doing a lot of technical support in general, and also adding core features to the sound engine and other enhancements as we're going to get into today.
Yeah, well,
Um,
and I know you from past live streams where we've talked about CPU performance, a fantastic deep dive under the hood. I know you from 24.1 and the Wise Arenas feature, a great feature that landed, squarely in developers' hands, trying to understand what's happening under the hood. So, really deep on the core engine side of things, and this live stream today has been a tremendous push towards bringing greater accessibility to some really fun stuff that people can use to do cool things with. So I'm looking forward to strapping in and taking the ride. Ready to go?
yeah, so kind of a lot of the problems that we're going to be talking about today is mostly to while trying to do some support for a lot of like larger scale titles over the last few years, where more and more titles are trying to have more interesting dynamics in their sound mix, um, which we've actually highlighted in the YouTube channel recently, with especially with a few shorts from Baldur's Gate 3 and also from Helldivers 2, showing and many other titles have been doing it,
Yeah,
like Spider-Man 2 and God of War Ragnarok in particular have
yeah,
been going really hard in this direction of doing a lot of really complex and heavyweight and very manual and cumbersome like filtering and metering of audio to try and just do things like um, I want to have one chunk of audio, the low frequency portion of some audio, act as a frequency based sidechain for another portion of audio in the same mix, and needing like 20 pieces in order to get that simple thing going. I mean, it's a bit extreme, but it's like
right.
20 pieces once you get 3 or 4 of those set up. And it's not just setup, it's also maintenance. It's cumbersome, it's prickly, it can break a lot. It's just really bad. And like there's one project that I worked on where I counted up how many buses they had. Buses just for metering, like not the actual like music or
Yeah,
UI or sound effects buses, just metering those components. It was over 50 buses, and I was like, okay, bro, we
yeah.
got to fix this. We got to fix this. This is so bad. You guys are. We need to fix this real badly.
Yeah.
Um,
And so we're seeing this happening in the community. The timing is finally right to
yeah,
take a bite out of it. And you're right. These techniques of carving out frequencies, using using the kick of your music to make sure that the explosion has the right impact, or vice versa. Finding the right fit for the sonics overall is something people have been reaching for in Wwise, and thankfully there's been a solution. But getting them there faster, well, that's the name of the game for us working with developers, is how can we reduce the friction to being able to achieve that creative vision.
yeah. So yeah, if we can flip over to Wwise, let's walk through first off the multiband meter.
Yeah,
Is that on screen now? Sorry,
yeah, you
I,
got it.
I can't see the live view for the people back at home.
Like
Um,
magic, we got you.
so to walk through a little bit of what some of the stuff looks like if I wanted to have some music uh, routed to, sorry, yeah, if I wanted to have some music be metered in a whole bunch of different ways, like I need a whole bunch of user-defined aux sends set up. That's close enough. Each with their own like EQ and meter effects just to do it. So we had that music that was playing earlier. If I wanted to meter it across multiple gain parameters, if I get it working. Wait, what did I set up just now?
I think that the lower one.
Oh, did I set it up on the property container?
Maybe it was music.
Okay, well, let's just set it up again, and we'll find out what I got wrong in just a moment.
It's part of the fun.
Yeah. I mean, this also shows like, hey, I just got it wrong in 2 seconds, so this is really problematic workflow.
Yeah.
All right, let's try that again. Oh, I see how I set it up. Yeah. Yeah. Okay. None, 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 and none. All right. I'm not sure that's going to terminate anytime soon. Come on. Okay. This might be here for a while. Sorry.
We're doing it live. This is the best part. And there's always something to be learned from watching someone else's workflow, especially when you're working through debugging a solution. I know I always have a lot to learn.
I'm going to just restart Wise. I'm not sure how I'm going to be able to correct that in 2 seconds.
Okay. Well, as we restart, folks who are joining us in the chat, give us some suggestions about things that you would use sidechaining to fix in a mix, like things that you think, would just be handy to have within reach so that you can, present the right mix on a moment-to-moment basis. Be interested in that.
Okay, let's try that.
Just some wild examples.
Sorry, let's try that one more time.
We're back to the screen. Yeah.
Oh, okay. How should you get out of there? There we go. That's what the problem was. Okay. So we have our music running. And like I said, like we're metering it, filtering in a whole bunch of different buses. And then we'll also have to set up a separate bus just to cut off the signal. And like I can go to, let me just turn the music down a little bit more. Like and as well, like if I want to look at these meters one by one, like I still need to go to each bus on its own and just see, okay, how's this meter responding? How's this meter responding? Like this is not great. So this specific workflow here of, hey, I want a filter, I want meters going to gain parameters, and then I want RTPCs. Or I want RTPCs driven by those gain parameters. We're trying to target that very directly with the multiband meter. And the way that we're going to do that is, so instead of having all these auxes here, I'm just going to have one aux, just to start, going to, how about get that? Going to this effect, this bus, which has this effect on it.
Great.
And now,
so this is that new multiband meter.
Yep, exactly.
Great.
So if I play the music now, so we have all the meters available on one panel. It's a large panel, but at the very least, it is a one-stop shop for everything. Main features are, like, this is a direct derivative of the existing Wwise meter. In fact, they're actually very linked in the back end in code, to the point, like, there's a lot of shared logic here. But we have a lot of similar properties, like you can control the mode, scope of the parameters, apply downstream volume, infinite hold. Works exactly the same as it does, but it works for across all the parameters at once. We have a meter for all the inputs, which can be not just a multi-channel signal, but a whole gang of audio objects. So when we take all this signal in, we mix it down into a single channel signal.
That's right.
A single channel signal. Say that 3 times fast. First, we meter that. And this meter, again, behaves exactly like the original meter does. You have attack, hold, release, min, max, all the ways to control a game parameter that you know and love, including specifying game parameter through the old controls. But as noted, we also, this is very obvious, we also then filter that down mixed signal into 4 separate components with user configurable low frequency and high frequency ranges for each meter, and as well customized roll off for each piece of the frequency range. So if I want to very tightly, because these are running like low passes and high pass filters, so I can have a roll off that's 12 dB per octave, which is a standard low pass filter, or I can run that multiple times to get 24, 36, and 48 dB per octave, which the higher ones can be useful if you want to have very precise measurement of frequency range. So those are all separately configurable for each parameter. You can actually have like multiple bands share the same parameter, like it all works the same way.
Yeah.
You have separate controls for each band. So if you want to have your lower frequency meter have a much longer release, you can do that separate from your much higher frequency measurements. So yeah, this is something where like we wanted to put this all into one place and also give people some extra functionality on top of it. And that's what the roll off and low frequency cuts are, is say like, okay, you want to do that, there's an easy way to set that up. But there's one other thing I also wanted to set up here, and that is, so right now in this setup that I just improvised here, we still have our bus music going to a separate aux. I mentioned the multiband meter now does a mix down internally of all the incoming objects and doesn't really touch the output signal. Like it just does an internal mix down, that's fine. What this means is you don't even necessarily need a separate aux bus just for your metering. Instead, you can just put it straight on your mainline bus. And right, I don't want that. I just want to cut this aux send here. Let's play that again. The nice thing about this is that there was a handful of little optimizations that we do in the sound engine processing, where if you can avoid an aux bus, that actually ends up being a nice little benefit in terms of runtime, performance, and memory considerations. But also it's just a bit easier to just have it all in one spot. Like who needs more buses when you can have fewer buses?
And right now, with only 4 user-defined auxes, use them for other things.
Yeah. But one other thing that we can do now that we just have it in line, is we can also solo specific bands of the meters, and that's what this listen button is. So I'm going to raise the volume of the multiband meter, because if I cut portions of the audio, then it's going to get lower anyways. But if we do this, so right now I'm just soloing just a lower frequency component, which can be really helpful if you want to really dial in these high frequency ranges or the roll-offs that you want. Like even though I'm listening to the low end here, I'm still getting some of those keys coming in, and I don't really want that. And that's where things like the higher roll-offs can, make sense.
Yeah.
Because now this doesn't have any of the keys.
Nice. And that just changes the slope.
Exactly, yeah.
Nice.
And you can obviously flip through the other ones and make sure, yeah, these are covering the right ranges, or these sound right, or just verify what is the audio driving this meter exactly. So again, that's something where we said like, okay, how can we improve the workflow just a bit longer, just a bit more, get a nice little bang for buck out of this, because this wasn't a costly feature to implement on top of the other stuff we were doing. We already had the signal. All we have to do is just spit it out the back end.
Nice. Well, and for folks who are already familiar with the workflow of metering game parameters and using those as RTPCs across objects, the multiband meter is just a supercharged workflow that gets you there faster.
So that's it for that. And I should also note, all that we're about to show for the Parametric EQ and Sidechain mixes to come, I think there is also still value on going for the multiband meter. Like, for one, it's just a nice way to just drop. If you're already doing this kind of filtering and metering, you can just drop the multiband meter in and don't have to change anything. So it's an easy migration, for one. Number two is there's still a lot of things that are really valuable about gain parameters, like being able to really very precisely control exactly how a specific RTPC responds to a gain parameter. Or if you want to have game parameters be queried by the game engine through the sound engine APIs, like that still exists and might be valuable through the multiband meter or through similar things like the multiband meter.
Yeah, totally. It builds a bridge, but also supercharges that workflow in a way we think really meets the experiences that developers have shared with us. So when you give it a try, let us know. I'm going to answer a question from the chat before we move on. Question from Miguel. Nice to see you here. Hey, transitioning from the 101 to the 201, I think you're going to have a easy ramp up between those. So definitely forge ahead. Even as a sound designer or music producer, you're going to be in good hands thanks to those certifications. And then the question of, Wwise 24.1, 25, should you upgrade? The certification has been built with 24.1, so it would benefit you to probably stick with that for now. And I would give 25 a shot after you make it through and see if you can spot the difference. There shouldn't be much change between versions when it comes to the 201 certification, but we'll be interested in hearing any feedback that you have. Another question coming in for you, David. Does the multiband meter replace ducking or auto ducking? Is this no? Is this the kind of thing that you would say is a replacement?
Well, it's not a replacement insofar as ducking on buses still exists. I assume, by the way, referring to this feature of the buses where you can just auto duck. If a target bus is active, then we'll lower the volume of this. Like the meter and multiband meter. The meter, you're already able to do this kind of stuff before. And auto ducking is still going to persist. This can be useful. I think there's you can probably have a lot of opinions on the value of the auto ducking. Like there is some value here of just saying, oh, is this bus active? Yes or no? Then lower us by a certain amount.
Yeah.
As opposed to measuring what is the actual audio flowing through that target bus, and then we're lowering our volume by a certain amount. Like different tools for different applications.
Exactly. I think still auto ducking still very valid. As you're saying, is the bus active? Essentially, is the bus receiving signal of some kind? And while it is, or if it is, then apply the ducking rules that are there, as opposed to the multiband meter or sidechaining, as we'll be talking about, which is a amplitude-based application as opposed to a signal or active-based application of dynamics.
Yeah. But yeah, certainly like auto ducking is still there. Like we're not taking the feature away.
No, some folks live by that feature, so definitely a good one to have in the toolbox.
So moving on then, let's talk about the parametric EQ. I actually really wish I still had a copy of Wwise 24.1 easily at hand in a snap. But I think if most people who have worked with it for so many years might be able to appreciate just what a jump we are taking in this release, especially given that it's like a bread and butter of a lot of like mixing and mastering that people are doing. So yeah, let's
just imagine numbers. Just imagine numbers.
Okay, so the primary EQ, right? So yeah, instead of just three components that are just like that you're blind to, like we have like a full graph derived from the Mastering Suite UI, if you're familiar with that. But it's now expanded to the Parametric EQ, so we have the ability to let me just turn this piano so we can changes in frequency. So we have like one EQ band here. I can click and drag it to easily control the frequency and gain of the effect. So
Yeah.
Actually, specifically for the low pass flat, which by the way, like low pass got renamed to low pass flat, high pass got renamed to high pass flat. I'll show what low pass and high pass are now in just a moment. But low pass flat, like you can still click and drag to change the frequency this way. For shelf like just a minute ago, peaking, we can also click and drag to change the frequency again, super rapidly, very quickly. We can see exactly what the frequency response is going to be. For band pass and notch, the click and drag here won't affect the gain, it'll affect the Q factor instead, which, again, really convenient for people using bands in that way. But of course, we don't just have one band. We can have, as Damien had noted earlier, we now can do up to 8 bands of processing in one parametric EQ effect.
Yeah.
So, of course, we show not just the individual contribution of each band, we show the total frequency response across the entire spectrum on this graph as well. So, again, you can still quickly see how is this going to affect the overall shape of the audio on this effect while I'm setting things up. Or while you're setting things up. Yeah, that's it for this bit.
Great, and bands can be enabled or disabled.
Oh, yes, yeah. I mean, sure, let's...
RTPC.
Get too far off. Yes, so all the existing properties... Oh, actually, sorry, I almost forgot about one thing here. I said I was going to talk about low pass flat and low pass. So yeah, low pass, this is now low pass with a resonance factor. This is also like click and drag changes the Q factor of this and changes the frequency. Ditto high pass with resonance. Also for the low pass and high pass filters, we have roll-offs available if you want to do like very precise shaping. Again, similar to what we did from Multiband Meter.
That's it.
If you just want like really precise cutoffs there.
Yeah, those new roll-offs are fantastic for getting exactly what you want.
Next, okay, EQ profile. So we also have the ability to solo specific bands in isolation. So right now in beta 3, let's turn that down a little bit. In beta 3, we have this UI marked as listen. This will get changed to a proper solo button. That'll be a little bit easier to work with, but it's functionally the same thing. So like right now, let me just turn that back up again. So we're just listening to what just band 2 is doing now by setting it to listen to. So I really narrow the Q factor of this, like we can see, okay, what frequency range am I affecting on this band? And then go back to the full band mix and be able to preview it that way.
Nice. So it's like a band solo, giving you that ear on what that band is doing. Yeah,
quite literally, actually. I think in the final version of this UI actually is referred to as solo specifically. And yes, it's similar to band soloing functionality in other professional and much more, or sorry, not to say Wwise is professional, Pro Tool plugins regarding EQs and that sort of thing.
There you go.
That some of our customers really like a lot.
Yeah. Question coming in from the chat.
Yeah.
Is there any, do we have randomizer on any of those properties, or
No,
I don't think so.
it's just RTPCs. It's the same RTPC functionality that the existing Parametric EQs have.
Yeah.
So the filter type is RTPCable, frequency is RTPCable, gain is RTPCable, and Q factor is RTPCable, and band enable and disable can be RTPC'd.
Yeah, and you can get it randomized from an LFO over on the modulator side in RTPCs. It's a way to go about it if you want to do something like that.
Was that all I had for this one? Yeah. So
James, nice to see you, by the way. Good question. Thanks.
Okay, Parametric EQ RTPC.
Dig into your modulators.
I don't have a modular demo set up, so I won't be able to show that off.
No.
I do have the next best thing though, which is so right. So a lot of folks also tend to, especially in regards to trying to set up their own like homegrown dynamic EQ, also attach RTPCs to various properties, as we were just talking about. One other feature that we have with the Parametric EQ now is the ability to preview what the runtime frequency response curve is based on all of the evaluated RTPCs.
Yes.
And that looks like this. So we have some seagulls playing in the background. And this is just a fake distance parameter I've set up just for auditioning purposes here. And this is driving all three gains, or the gains of the three bands we have active here. And as I change this parameter here, which would be the same as if you were doing it in the runtime, and again, this is just auditioning for Wwise authoring. As I change it, we have this preview of what is the frequency response in the runtime.
Amazing.
Yeah, like this is one of those things where there's actually one project I went back to just for reference for this, and I realized like, oh, you guys, they actually had like the incorrect queue set up here. Like they had a queue of, I think it was like 2 or something like that for this middle pass here for simulating error attenuation. And I don't think they realized like, hey, this is actually going to be like a really weird little spike in the curve that you would not have been able to see before.
Yeah.
But now it's just a lot easier to see that and go like, oh, that's not right. That should be down like this. So you can have a much more stable frequency response across that midband in this spectrum, in this example, for example. But yeah, like you have this like runtime preview of like, again, what we're evaluating the RTPCs to. In this example, I have it set up for band, for the band gains, but this would apply even if I had this set up for frequency, Q, even filter type, actually. In fact, you know, let's improvise a bit. Let's do a little bit of fun and set this up onto the filter type. And make a real pile of nonsense here. So, like, as I change this in parameter, the filter type will change from high shelf to notch, and you can just see how that responds at runtime. Again, this is only when you actually have the Parametric EQ effect running. I can't do auditioning of the effect while I'm not playing any sound through it. We're not that kind of magic. But it does show you, what is the runtime doing.
Right, and that's because you are both capturing and live while that effect is processing audio.
Yeah, exactly. And next, so we've been talking about, we have dynamics on the Parametric EQ as well. So I have this pre-configured for band 1 and band 2. Let me just get a little bit more in here.
Oh, it's just a beauty to watch.
Yeah, so right now, this is just measuring... sorry, yes, it is, by the way. When another member of the core team, Michael Cooper, got this online, like, I was like, yes, this is awesome! Like, I was floored by it. I think this is really exciting to see this level of animation in the tool and this level of precision as well, because we are capturing every sound engine tick in this regard right now. And so these dynamics right now, like this band 1 and band 2, they are set up with different, we're set up with different thresholds, different attacks and releases, which are a little bit derived from the compressor-based attack and release definitions, if I remember correctly. And it is just when we have dynamics active on a signal, we're going to filter it in for each band based off of what we're listening, or filter it to isolate to a specific band, and then meter how loud that band is. And then the volume of that relative to the threshold set for that band is then used in conjunction with the maximum range specified for that band, which in the case of band 1, we have a negative range here, so this will act as a bit of compression. On band 2, we have a positive range, so this is going to act as a bit of expansion. So you can see as I change the maximum range here, this is going to affect what the total gain offset can be. But yeah, so with the threshold and range, we are then able to calculate a new gain offset for that band. And it's a gain offset because this is a value added to the evaluated gain of that band. And that includes any RTPC evaluation of that parameter. So the dynamics can combine with RTPCs that you may have set up, and it's just purely additive. I mean, the RTPCs for gains are already set to be additive if you have multiple gains set up. This is one other contributor to that. And being able to use the audio signal directly as opposed to only being able to rely on gain parameters and RTPCs.
We're getting like huge like cheers in the chats, you know.
I don't have chat on screen, so I'll take your word for it.
Loving the EQ, awesomes. It's great to see it in action. And this is all, working on the audio signal. Again,
and right now,
I thought you explained it really well.
And right now, like, I mean, astute viewers will notice that there's an option here that I'm not poking just yet. Right now, we're only measuring the inline audio signal, which can be useful in a lot of cases. So I want a simple parametric EQ that acts as a de-esser or whatever it is. Or I've combined my wet and dry reverb and main mix, and I want to filter out the reverb in some way. Well, maybe I want dynamic EQ to cut the reverb in some way, something like that. Inline audio signal can be good for some things. But we also need a way to drive this through an alternative audio signal. And for that, let's talk about sidechain mixes. And that's your cue, Damien.
Let's go. Here we go. We've got the sidechain mix presentation up and ready to go. So, new feature, sidechain mix.
Yeah. So as I mentioned, like right now, when we are running effect plugins on buses or voices, they could only be affected by RTPCs and /gain parameters. I should not have written game properties there. So sidechain mix is a new feature available for effect plugins to be able to send and receive multi-channel audio signals as a part of the processing of that effect.
And this multi-channel piece is key.
It will be key. Right now, this is a bit of a spoiler. Right now, all of our systems that we're doing just do mix downs of the sidechain mix, but there might be something in the future or that third-party plugin developers might want to do that uses that. But right now, everything is just mono. But maybe there's some things you might want to do in the future. Cool. But yeah. So it's a new share set type that you'll see in the Project Explorer under sidechain mixes. We did have it under effects in an earlier beta, but some folks were like, this doesn't work as well as we thought it did. Yeah. So it's just in a separate category now, but it is a separate share set, just like everything else. Part of this is, or in terms of getting baseline infrastructure set up, we have a sidechain send effect plugin that is now available for buses, which can be used to take the input audio signal into that effect and adds it to the specified sidechain mix. I'll note that this is an effect plugin. Even though sidechain mixes as a concept are part of the Wwise architecture now, it's not like we have buses sent to sidechain sends or sent to sidechain mixes. We have effects that can do it. And there's a couple of reasons for that. One is it's a little bit easier for us to construct and maintain things if we have things just as an effect plugin instead of a built-in feature of every single bus in the game. But two, it also gives a lot more flexibility for us in the future and potentially a lot of third-party plugin developers to apply their own custom processing to how sidechain mixes operate and allow, like especially for third-party plugin developers, allow them to innovate in ways that maybe we can't or don't have the time to, or maybe just have some unique problem that you need to address that we can't address in a general way. Like maybe you want to do some specific processing for individual channels, or you want to do some specific filtering before you send to a sidechain mix, or the way that we're doing a down mix into a sidechain mix. You don't really like how that works. You want the slightly different volume computation, something like that. Like that option is available for third-party developers to do, and that's why we are making this a part of an effect plugin infrastructure and not a part of like the core sound engine, in the sense of like be putting it onto buses like auto ducking, for to go call back a little bit.
Yeah. Well, and another benefit is that you can slot this anywhere in the effects chain. So now if you want to take the sidechain mix before you hit the distortion hard or the reverb, you have control over where that gets sent from.
Exactly. And now that as of recently, you can have more than 4 effects per bus. Like maybe you do want to have like a rack of effects and you just want your sidechain send in the middle of that.
Yeah.
Like that's one more reason why it just makes it a little bit more flexible to work with.
Almost unlimited effects slots. Almost.
Unlimited enough that if you're running into problems with that limitation, you're going to run into other problems first with performance and that kind of thing.
The limitation is 255, so
yeah.
Good luck. We still haven't heard back. It's been out since 23.1, I believe, and no one has broke that limit yet, so keep us posted.
So in addition to sidechain sending, let's move on. In addition to sidechain sends, we also have the sidechain receive effect. This is something that we just have available. I don't expect this to have many practical applications because all that this is doing is it reads an audio signal from a sidechain mix, and that becomes the output audio of the effect. Our main intent for this is like profiling and debugging. Like what is in this sidechain mix? The answer to that question will be solved. Sorry, that question will be answered by using the sidechain receive plugin. Like if you just want to see like what is driving it, what is going on here, like why is this responding in this way? Sidechain receive is what you have. And next, so the compressor and expander effects have been added with sidechain mix support, and they've also had a few other bells and whistles added. Like there's a channel link percentage if you want to have some channel unlinked processing, but you don't want each channel one by one. We have a little cross between that now, and a little bit other support to allow you to view minor reductions in your gain more easily. But the main thing here is that you can also have a sidechain input to drive that. Sorry, you can have sidechain input to drive that gain reduction, as opposed to using the inline input on its own. So like again, it's one thing where like you could do this with gain parameters. You could have a gain effect that is modulated based off of other meters and RTPCs and gain parameters. But this is also something where maybe it's just easier to work with and think about and reason about audio signals and relative loudness in that regard, and just use sidechains for that.
Right, and that takes one of those sidechain mix share sets as its input.
Yes, yeah, and in this picture here, you can see in the bottom left where we specified the sidechain mix as a share set. And you specify that share set like you would gain parameter, which we'll show you that later in the presentation as well.
Great. And that's scoped global or per game object?
We'll talk about that in a minute.
Moving forward quickly.
So Sidechain Mix, it supports different channel configurations. So as we said, multi-channel signals may be useful for some channel unlinked compression that you might have. But in general, I think like most of the time, I think you're going to want mono sidechain mixes. There's only some exotic scenarios where you're going to want to have more and more multi-channel signals for that. In terms of the channel configurations available, you can specify like classic bus configs. You can have 1.0, 2.0, 4.0, 5.1, 7.1, 7.1.4, ambisonic 1, 2, 3, 4, 5. Unlike buses, though, buses you would have same as parent and same as main mix and same as pass-through mix as specific specialized configurations that can be set. For the sidechain mix, we have something similar but a little bit different. We have same as primary main mix and same as primary pass-through mix. What that does is it will look at the primary output device in the sound that's running in the sound engine and query what is the main mix on that, what is the pass-through mix on that. That follows the same rules as the same as main mix and same as pass-through mix settings that you would have on a bus. And that might be useful for some situations where, yeah, I want this to match what my primary device's main mix is. Exactly.
Right. And scenario where you'd have more than one system audio device that it looks at. I guess motion bus or...
Yeah, that's why. So primary output device is really important for that. Yeah. Because like with a bus, when we have same as main mix, we can walk the bus hierarchy and figure out, okay, this bus is parented or is a child of this bus, and this bus, and go on until we hit the output device, and we then we'll query the output device. What is your main mix? What is your pass-through mix? What is your config? What are you?
Yeah.
Buses can walk through that graph, but sidechain mixes act in a bit of a more ethereal capacity and don't have a direct connection to an output device or even an implicit connection to an output device. So we have the primary device as something that is a touchstone that we know we can go to. It's one point, it's reliable, it's consistent, simple to define, and that will typically be your system output device. The primary output device is a special concept we have in Wwise, which is a little bit obscure, but in most cases, it's just the system output device.
Perfect.
Yeah, so it's not your motion bus, it's not your secondary like gamepad speaker and that kind of stuff. It should be your main system output all the time.
Perfect. Thanks for the clarification.
And unlike buses, we do not have audio objects as a config for sidechain mixes. A sidechain mix is always going to be one signal for all input and output, all sending and receiving. We're dealing with one audio signal. Having audio objects as a concept would explode the complexity of that in about 20 different ways and might not be very valuable. Like we think that, especially since sidechain mixes are supposed to be more implicit forms of audio objects are not really what we're looking for this. So
perfect.
No audio objects, but we do have a wide variety of other channel configurations available.
Perfect.
So that's the overview of what the sidechain mix is in terms of actually configuring it. If we go on.
Yeah.
So as we mentioned, so I actually can't tell if you're on the next slide or not.
I'm here. Send and receive. Scoped.
Oh, I jumped forward. Sorry. Yes. So yes, as Damien asked about, we do have a scope specified on our default stock plugins. I'll talk about this a bit more in terms of what the actual backend is for plugin developers. But for the stock Wwise plugins, we have two modes of operation for what the scope of a sidechain mix is. It can be global, where like it's operated at a global scope, or it can be constrained to specific game objects. So the obvious one is if you want to have a split screen audio and you want sidechain mixes to only affect itself inside that one split screen view you have, great. You can use the game object scope to limit the sidechain mix consumption or receiving in that regard, and receiving. Sorry.
Perfect. So in a game like Split Fiction, you can make sure that all of this sound stays scoped to player 1 and all of the other sound gets scoped to player 2.
It's funny, man. That would be a simple way of putting it. I imagine the plugin developers at Hazelight are there's an impressive thread posted by I forget his name, one of the
It's
developers at Hazelight,
yeah.
on a whole bunch of the plugins that they have developed, and there's some really interesting things that they have, and actually a couple ones that I think they might be really excited about. I hope to hear more from them. But yes, for a split screen application, that is a clear example of that. And again, this is just regards to our built-in plugins that we offer in Wwise. We have these two modes, but there might be something else later on for some other plugin developers to look at and consider.
Cool.
So next, so any effect on a bus can send to a sidechain mix. Any effect on a bus can receive from a sidechain mix. This is a really flexible way to work, but with all things in problem solving in general, this kind of stuff, programming, whatever you want to call it, this flexibility does come at a little bit of a cost. And that is receiving of a sidechain mix is always going to be delayed from sending by the duration of time of one audio render pass. So if your default sound engine configuration processes 10 milliseconds of audio per tick, then your sidechain mix receiving is going to be delayed by 10 milliseconds. This was something we did consider a lot when we were thinking about this problem. Like how do we set up sidechain mixes? And this was a cost that we thought was relatively acceptable given most of the applications that we have seen for sidechain like compressing or processing and compressing in most shipping titles today. And where like you would have longer compressions. Like there aren't a ton of scenarios where people are doing things like I want millisecond precise kick and bass responses or that kind of thing, or I want like this gunshot to respond or to drive the compression on music in less than a millisecond or in almost a millisecond. There aren't a ton of those applications, but we do have a little bit of affordance. We do have a little bit of affordance in that regard, which I'll talk to in a bit. We can go to the next slide.
Yep.
I wanted to show this as a really simple visualization of how we go from send to receive on a sidechain mix. So we don't process a sidechain mix inside the same sound engine tick. Instead, whenever you're sending it on one bus graph or during one execution of the bus graph, we send that to a central repository of sidechain mixes that get accumulated together at the end of a sound engine tick. And then those will be ready for processing on the next sound engine tick. So the flow of data is not just in one graph on its own, like a feedback loop that we have or existing bus connections. Instead, this is a connection that exists implicitly over time from one instance of the bus graph to another instance of the bus graph. So I hope this might help clarify exactly what the flow of data is in this regard. To help clarify, this is how the delay works.
Yeah, makes sense.
In terms of what the delay actually looks like, this is representation of one of our internal tests, or to showcase what this looks like, where we have a sidechain. The stereo signal in the top two channels is being sent to a sidechain, and then we have a third channel that was receiving that sidechain. And this rectified waveform here, we can see that the receiving, and it's the same sound effect that's on the send and receive, but on the receiving end, it's delayed by 10 milliseconds in this example. But if we go to the next slide, one of the options that are available on sidechain send effects is a little checkbox called delay output, which just has that whatever signal is coming into the sidechain effect, even though we're sending it to the sidechain mix, we're also going to do an inline delay of it of one audio render tick, which in this case, for example, it's enough to get the send delayed 10 milliseconds and then synchronized with the receiving side of the audio signal as well. So the effect is resynchronized. Yay! Of course, this does come at, we traded one cost for another cost. And that main cost is that your inline sidechain mix is now, or input into the sidechain mix has also been delayed by 10 milliseconds. In a lot of scenarios, that's probably fine. Like the synchronization of music tracks is probably way more important than a 10 millisecond delay in a user animation resulting in a change, or user interaction resulting in a change in the interactive music that you have. Like, oh well, if that's delayed by 10 milliseconds, who cares? But if you want to do that for like gunshots, maybe that'll be a little bit, or UI sound effects, that might be a little bit too impactful, and you might want to back off hitting that delay output for everything there, or at least want to make sure that you're not stacking that multiple times. Because if you have 5 in a row, you're delaying it 5 times before you actually get the output signal, and that can be really bad as well. So,
and this feature really, to me, speaks to just the flexibility of allowing folks to use their ears to determine the right precision for their use of the sidechain effect.
Yeah.
Great feature to have.
Yeah, so if we go...
Some scenarios might need that.
Yeah, I mean, this, in the discussions we've been having with a lot of sound designers that were prototyping this or doing early evaluation of this wasn't something that came up very directly of like, I actually do want that synchronization. It's like, okay, well, all right, let's see what we can do here. Let's get something up that's really easy. And this is what we came up with. But enough slides. Let's get back to Wwise.
Yeah.
Let's see what the sidechain mix actually looks like in action.
Ooh, nice to see you, Guido. Yeah. Always
actually,
before we
go forward, are there any questions in the chat about this?
No questions coming in. We got a lovely feature, the sidechain mix from Guido. It's great to have Brian here. Really elegant solution to a tricky problem. Synchronized output might be a better name for the checkbox. Interesting. Again, they told me when I started here, naming is the hardest part of the job. And yeah, the difference between something like synchronized output and then just the literal delay output. Yeah, it's a good suggestion.
Yeah, that's an interesting one. I'll actually register my opinion on that, if you don't mind.
Do it. Yeah.
So, for one, delay output does more directly describe exactly what the mechanism is internally. Like, it is internal delay. We're just double buffering the audio signal for one tick. But as well, I think, like, if you had multiple sidechain sends in a row and they were all saying synchronized output, you might not necessarily, or certainly a new user might not necessarily think like, oh, like my sound is now like 40 milliseconds delayed. What happened? I had synchronized output on all of these, but everything's delayed. Everything's like really slow and latent. Well, it's because the synchronized output is actually delaying the signal. It's like, so,
yeah.
It's okay. That kind of thing where I would prefer to keep it as delay output, frankly.
Yeah. Well, and we're listening, so keep the feedback coming, and let's just keep finding the right way through. Question coming in from Guido. When you have multiple side chains with delayed outputs, so Guido, you're saying multiple sidechain mixes, are those delays done at the same tick?
Since we're still getting used to the terminology here, I think that there might be two versions of those questions that are answered, and I'm trying to answer actually both of them. Cool. First is, if you have, if you have multiple instances of a sidechain send in action and all going to one sidechain mix, and this is point up here. This is also why sidechain mix is called sidechain mix. If you have multiple sidechain sends, getting some audio in and sending it to a sidechain mix, all of those will be accumulated together on the same sound engine tick. Like, if we actually go back in the slide here, can you go to slide 10, Damien, please?
Yeah, on my way.
I guess slide 10 of the alternative presentation I sent you.
Yeah, you bet. I wonder which one it is, slide 10.
Yeah, it's the diagram one. Oh, yeah, you don't have the numbers. It's the diagram with two voice graphs and the sidechain mix in the middle.
Perfect. Yeah, got it.
So if you had multiple sidechain sends on that voice graph on the left, those would all be accumulating to one target sidechain mix. And that's all resolved at the end of the sound engine tick, and the accumulated mix is available for any reception on the back end. The other version of your question I think you might be asking is, if you have multiple sidechain sends with delayed outputs, because the sidechain send effect with a delayed output enabled is actually modifying the signal going through the effect. Like that sidechain send is going to do an inline delay of that signal, and that might go to the next sidechain send effect in your rack, and that's also going to do a delay for one tick, and that's going to send to the next sidechain send, and that'll also do a delay, and so on. So that's how you would have a delay stacking up, is if you had multiple sidechain sends in a row, either on a bus or on successive buses, that all had delay output active. Each one of those that have delay output active is doing an active transformation of the inline audio signal through your bus graph. So I get that will delay it multiple ticks, but each effect is processing on the same tick, because it's an effect just like every other effect. They all get processed on the same tick if they're active. But that's what the delay output is actually doing when you're running that on an effect.
Awesome. Thorough explanation. Something you've been hinting at here, or maybe just not overtly saying out loud, is all of this is in the box for plugin developers with Beta 3.
Yes, it is. Yeah, like all that we're talking about here and all that we're showing today, this is all available in Beta 3 today. Like if you get the Wwise launcher, you can just try it yourself at home. And we'll be talking a little bit before the end of the presentation about what this means for plugin developers, which, if I remember correctly, Guido, you are someone who is very active on a plugin developer. So don't worry, we got something for you coming up at the end. Don't you wait.
Awesome. So stick around for that. And thanks for the questions, folks. Keep them coming, and we're going to move forward. Let's roll.
So if we go back to Wwise, I assume Wwise is back on screen, Damien?
Here it comes.
So, okay, so this should be set up for the compressor already. I'm just double checking my work.
Guido sends us thanks for that explanation.
Wait, no, that's not. Okay, you know what, it's easier for me to just watch it and recall exactly how I set things up. Okay, so in this setup here, if we look at the voice graph on the bottom, the piano sound that's playing is going out to our sidechain bus music with a sidechain send effect on it, which we can see in the Project Explorer here. Again, it's a separate share set, just like everything else here. And you can hear as the piano is going, mute this. Like the piano sound that's playing is driving the input to it, and we're also sending down to a single channel sidechain mix right now, and that's what we're previewing here in this instance of the sidechain send effect. And then on the separate from the music that we have, that we also have a whole bunch of nice seagulls and ocean waves coming through as well. And I've got two effects here for auditioning, one being a compressor and one being a parametric EQ. I'll show you the compressor first to show you how this is operating in action. So if I go back to here. So again, as we turn the piano music back on, this will start sending to the sidechain mix again. And we will see the response now in our sidechain bus, world compressor bus that we have. So again, as the piano is going, we can see the sidechain input being driven up and down. And the higher volumes of the piano is driving the gain reduction on the seagulls and waves.
Awesome. And that's simple sidechaining right there.
Yeah, this is our most simple version of sidechain that we have. Actually, so I can see there, like as I turn on and off, like that clearly like caused the seagulls and ocean to get louder and quieter. But this is like really easy to set up, really convenient. But Compressor operates in a full band capacity.
But it's so great to see this simple execution, because again, you're coming from a DAW background or a music background.
You're just thinking in terms of audio, not gain parameters.
Yeah.
That sounds like computer talk.
Right? You understand the concept. You know that it comes from an audio context, and now closing that loop in Wwise, using audio to drive audio is just so much more accessible. Really nice work.
Also, while I was showing off, like, here is how you set up the sidechain input in your compressor. This should be really simple. Of course, this is also available in the multi-editor for effects as well, as an additional object that you can reference in a plugin.
Awesome.
I'll talk about that later. But
okay, so see you, Brian. Thanks for visiting. He says, thanks for raising the bar for interactive mixing. You could even say it's a game-changing gain changer.
Oh,
Badoo.
Most things that are game changers do change the game.
What's the equivalent on the bass for that? Badoo, bow. Thanks, Brian. All right.
So that's for the compressor. So that's for the compressor effect. Really simple. Everyone, I'm sure, can understand exactly how that works. But we also have this available on the Parametric EQ. As we discussed before, when we're talking about an audio signal being able to drive the dynamics, we had the inline audio signal before, but we can also have the sidechain mix also be an alternative audio signal to drive the dynamics of a Parametric EQ effect as well. Piano takes a little bit of time to warm up, and of course, like being in dynamics, like a typical dynamics processing in Parametric EQ, like that's additive to any RTPCs you might set. It is going to be separate from doing any inline measurement of the dynamics. Like it's either you do inline measurement of the audio or you do the sidechain mix. We don't have a cross between those. If you want to cross between them, file a suggestion, file some feedback. We love feedback. It's a really good way to prioritize what work we should or should not do. I mentioned before, we have the ability to solo specific bands of your inline audio signal. Also note, we also have the ability to solo which band of the dynamics input is happening as well. So if we show this off, so if I mute the sidechain mix, so we're only listening to the world-based sound effects that we have, the ocean waves and seagulls. By the way, we still have the sidechain mix is still running. We still have send and receives happening. And you can tell, like, if I go back to SC Bus Music, I tell my sidechain send, like, we're still active. We're still sending audio to the sidechain mix. And we are also still responding to it on the Parametric EQ effect, even though I've muted the bus. Because we're listening to the effect of this Parametric EQ, we can also listen to the soloed specific bands of the sidechain mix as a dynamics input. So in this way, we can also use that to better track, like, okay, which frequency do we actually want to measure? Because, like, if we start off too high with this, like, oh, we thought that the piano was mostly in the 7K to 10K range. But if we actually listen to it and metered it, kind of like there's not much audio there. Like, most of the piano is coming from these, like, middle frequencies around, like, 1 to 2 kilohertz. So being able to solo the dynamics input in this way can help isolate what you're looking for. If you want, like, the dominant part of some portion of the audio to duck some other part as well. And again, this also, again, the piano mix takes a little bit to loop around sometimes. Yeah. Also, this preview, similar to other DAW tools that we have or that people do use, like the Q factor, as we narrow it, this does narrow what band of the audio we're going to listen to as well. So again, like all the stuff you would want to use to preview or to answer the question, what is the audio I'm affecting, or what is the audio driving this dynamics, can be handled through these solos functionality or through dynamics listening right now.
Amazing.
Yeah, and similarly to get the obverse of that and a little bit of a better view. Like this way, we're able to listen to which portion of the audio are we actually affecting with this band as well. Because one nice thing about this setup compared to the compressor is we're able to find which portion of the audio of the seagulls and the piano are overlapping. So we only duck that portion of the audio, but not like the ocean waves, which are a much lower frequency down here. If I try again, we can hear that a little bit better. Like all this roaring ocean, maybe we don't want to cut that. We only want to cut the seagulls because they're clashing too much with the piano.
Yeah.
Like again, this kind of exercise is a thing that is a lot more. It's comprehensible. Not even it's comprehensible. It's possible. I would say this is borderline not possible to do on the old Parametric EQ effect.
Right.
Now it is though.
Yeah, and this is something we hear about a lot. Folks wanting to carve out parts of the soundtrack of the frequency spectrum for different parts of the mix. You know, how can I use this on that? And this is a perfect example of that. Someone threw in the suggestion earlier of, you know, explosions, using explosions to duck things, you know, the low frequency of an explosion. I think this is another example where, yeah, when that's happening, it's probably the most important thing, and you want to get the low frequency of an ambient or these ocean rumble. You want to get that out of the way. So applying that as dynamics from an explosion sidechain mix makes perfect sense.
One example when I was doing some last minute prep over the weekend, one example I saw that might come up in some games is maybe you want to have a lot of like really important story dialogue that like needs to override everything else, or needs to come through with a perfect clarity as perfect as you can get reasonably. But if you're in an environment that has a lot of reverb, a lot of like really wet reverb, long and loud, maybe like your art director says, "Oh, we want the reverb a lot. We want to show."
Take the music down just a little bit when it's playing.
Oh, sorry about that.
That's okay. We want to hear you. You're spitting facts.
Okay. Maybe you want like a really heavy wet reverb. Your art director says like, "Oh, we have these huge caves and we have this huge church that you're in, the huge cathedral. We really want to showcase how loud the reverb is in this area." But your narrow director is saying like, "But we can't then hear the characters." Like, well, that's where you can come in and say, "Well, I can have the dialogue cut the reverb when the dialogue is playing in a way that only like where it's only clashing with those frequencies, or just in general as a whole, like either compressor or dynamic EQ in that regard, to try and solve that problem and make everyone happy."
Yeah. Well, and coming from, you know, the conversation we were having about auto ducking as a signal based ducking through to, you know, metered, now sidechain, it's almost like as we've arrived here with dynamics in the EQ, it's like lasers compared to hammers, right? It's like you've got this very specific problem you're trying to solve in the frequency spectrum as part of your dynamic mix, and now you just got lasers to fix it.
Yeah. Increased clarity, precision, and also greater ease of use across the board is what we're trying to target with this.
Yeah.
So yeah, I can't wait to see how people start to use this in action. I think there's going to be a bit of a blue ocean out there in terms of documentation and application for these kinds of things. Like you can go onto YouTube and find maybe not a million, but just about that much of examples of like, oh, here's how you can use a sidechain for kick and bass in your music and dynamic EQs to drive the chorus and all that in your music. but there's nothing for like, or very, 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 very little for like linear media, like film and television or games. I think it's something where a lot of people can probably share a lot of experimentation, or do a lot of experimentation, and then share a lot of knowledge and results of that experimentation as they go.
Yeah.
Because I think there's a lot of interesting applications for being able to shape an audio mix especially in interactive games where these scenarios are just so much more uncontrolled than what you would have in, film even.
It's true.
But you still want to have like clear. You still want to have a lot of clarity in your mix. That's the word I'm looking for that I'm muddling over.
Yeah, that's cool. I'm throwing it back to a presentation I saw about the game Crackdown 3. Christopher Melroth was given a presentation talking about, using explosions and the bass frequencies to duck out kick drums on a stemmed interactive mix. Getting that out of the way. The explosion is the most important thing. Clear out some of that low frequencies. And similarly, snare drums hitting at the same frequency spectrum as machine guns in that game. And again, using that machine gun to get the snare out of the way when you're in combat. And I think we have an emerging use case for this technique, and it just got easier for everyone. It's no longer the multiple meter game parameter scenario. It is all right there for you to solve these problems within your interactive mix.
Yeah, like you're thinking of Crackdown 3. I think my go-to is more recently there was a presentation that Andrew Quinn at Rocksteady Studios gave for all of the work done around Suicide Squad Kill the Justice League. That was at GDC 2024, I think.
Yep.
Which is a really valuable touchstone for us of like, I mean, we've got a lot of touchstones, a lot of user input, but this is one particular one where, they're really tackling this problem in a huge way because that game had a lot of complexity in their mix that they probably had to spend a lot of time trying to get back under control. And like, to their credit, I think they did in that regard. I mean, the audio mix is still, like, all things considered, like, pretty good.
Well, then it's a testament to Wwise that these capabilities exist and have existed in various forms. And I think it's a beautiful thing that we have these conversations with developers reaching for these complexities, that we're able to learn from them and iterate forward towards tools like what's in the box with 25.1. The multiband meter, the sidechain mix share set, the addition in the compressor, and now in the parametric EQ. There's just a new possibility for folks out there who need to tune their dynamic mixes. We're super excited about it. You ready for a question?
Yeah,
Coming
I am.
in from
I'm already
Guido.
looking at it.
Is the multi-channel effect CPU intensive?
Did you mean multiband effect?
Yeah, good question. Yeah, okay, sorry, he followed up. Yes, multiband. Multiband meter, is it CPU intensive?
Yeah, same thing as before. I think there's two questions that you might be asking. I'll answer both of them. Multiband meter is super cheap, relatively speaking. Especially one of the things that one of the motivating factors for the multiband meter was not just like user workflow improving that. It was also to try and reduce overall CPU time. Especially if you can get this, like, just have this in line on your audio bus. This can be a little bit cheaper than trying to have the same effect split across into like 4 Parametric EQs, 4 meters. Because especially if you're doing, like, let's say you have one main bus that has like dozens of audio objects going through it. If you have those going out to 4 user-defined auxes, we're going to do 4 separate mixdowns of all of those audio objects. And then we're also doing single channel filtering of each object on its own, and then also doing metering of that result. Having the multiband meter, we do this mixdown once for one. So like that's the savings right there. Number two is the filtering that we're doing for the bands is actually, there's a different, like, even though you could say, oh, it's like 4 channels that you're filtering in 4 different ways. Is that the same thing? Well, no. In this case, the way that we're actually running things on the CPU, this running 4 filters like this is about as costly as doing like 2 filters that are just by themselves. So by coalescing these together into like one pass, one filter bank, it does make this effect a lot cheaper to run. And this is really cheap to run, like maybe on the order of a few dozen microseconds on consoles, on most typical consoles these days. For the other version of the question of, oh, well, if we have this on the for the Parametric EQ, it's also pretty cheap here. It is, I mean, it's more work, it's more expensive, like it's not going to be more work done for less. But it's not much, because what we're doing here, it's still pretty coarse. Actually, that maybe is one important point to touch on here. We are doing metering of the dynamics across multiple bands, and filtering for the multiple bands is similar to the multiband meter. Pretty cheap to do. It's, it's not zero, but it's also like done in a couple micros. It's very quick and easy. But we're also just calculating the meter for each channel of the dynamics one at a time, and using that result for the entire processing of the Parametric EQ effect for that tick of the audio rendering. Like, we're not doing like a really advanced dynamic EQ where we're updating the internal biquad coefficients per sample or per 16 samples. No, it's like if your sound engine tick granularity is 512 samples for one sound engine tick, we're using the same coefficients for all 512 samples. So that is maybe worth noting, and not just in terms of, oh, this actually does moderate the CPU cost quite a bit, to the point that it is actually very reasonable to have this on a lot of effects. But also, if you're looking for extremely rapid changes in your dynamic EQ, you might be looking at the wrong spot. Or you might want to say like, hey, can you guys set up something that does operate at an extremely high granularity, because I do want millisecond level precision in my dynamic EQ? Because right now we don't. Right now it is operating at the same granularity as RTPC evaluation on the Parametric EQ effect would. Like, it's going to use these one coefficients for the entire sound engine tick for executing this instance of the effect. Whether it's value new gain parameters or you have a new gain offset applied as a part of your dynamics measurement.
Yeah, and I think we're always trying to strike the balance, right, between this kind of, extreme precision, microsecond execution, and just wide usability, right? And somewhere in there is the balance, right? Being able to use it everywhere without concern, versus really having to deliberate over its use. I think we are trying to find that middle spot, but keep us posted and let us know how that lands. And I have to say, this is why I love bringing the smart people to Wise Up on Air. David goes all the way from ticks to microseconds to all the way down to where we're operating right here in the moment on Wise Up on Air. So good to have you here, David.
Yeah, because people have noticed, like, we have worked on CPU timeline a little bit, and this is a very coarse example because this is measuring on a high-end desktop PC right now. But like, we do have one instance of the effect with which dynamics can be like 20 to 30 micros for all its processing that we're doing. But if I
Nice.
Mouse wheel dragged over a little bit. What if I turn off the little bit of dynamics processing? Because if you turn on dynamics for a little bit, we do a lot of extra work for all the dynamics. So like, if it's one or nothing for what it's worth. What if we cut that off? We lower it from 24 to 6 micros in this case. But that's also because this metering is also on a single channel mixed down signal. This might as well be constant for at least the dynamics measurement is effectively constant for however wide your input processing is. Like, we're just collecting the same coefficients for all the channels, for all audio objects that we have that are flowing through this Parametric EQ effect, by the way.
Nice.
Um,
And it's fun to watch that CPU profiler cruise.
this has been extraordinarily valuable for us to help answer a lot of questions, and I hope. I just lost my camera. Sorry, just stand by for one moment, please.
No problem. All good. Yeah, if folks haven't seen the CPU profiler yet as part of the advanced profiler, show it to your engineering team. Blow some minds, make some friends. It's a great way to get right down to a frame-by-frame execution of what's going on. This is the kind of tool that not everyone across the team of game development has. And so, let them know that this is the level of detail that we're operating on, that you can present to them, and that is part of your Wwise workflow. All right, good to have you back.
Yeah, sorry. There's always a technical problem on these things, isn't there?
Hey, we roll with it.
So that's enough out of the Wwise application. Guido, it's time to lock in because we're going to talk about some code, actually. And it's the last thing we want to talk about today with the sidechain mix stuff. So I want to talk about a little bit on some additions to functionality available for plugins for the part of the sidechain mix story. Because again, part of defining what the sidechain mix is going to be, we didn't want this to be some feature that is exclusive to Wwise, or you know what? I guess mine has just had the camera off for the rest of this. They need some time to cool down, literally. Sorry about that. So we didn't want to have this feature
lip sync.
No, that's fine. I think we just having the code on screen should be quite adequate.
Okay, cool.
So we didn't want to have this functionality be exclusive only to Wwise plugins. We also want this to be available to third-party plugins for all the reasons mentioned before. Like, there's a lot of potential here, a lot of room for like independent innovation, and we have seen some third-party plugins that are trying to do very, very similar things to what we're doing. So clearly, there is an appetite for this exact functionality. So there's a few things that we added. So here is the part of the back end for the compressor effect that exists in the Wwise authoring tool. So this is mostly used for just wrangling together parameters and doing serialization out to the sound bank. One of the things that we've added is, in addition to the property set that we have, actually, I know I should get one more file up here that I just realized I'm missing. Okay, compressor XML. Yeah, in addition to all the properties and property sets that we also have the ability to reference other objects that exist in your Wwise project. That can be added with a request reference set as an additional interface on your plugin class in authoring. And then also in your XML, you have your list of properties for everything that you have. And then you also have a new reference type available where you can define things like the basic properties it will be, and also what type it should be for the purposes of our UI tool. So we know, okay, filter down to just sidechain mixes when you want to set up your sidechain reference, whatever you're referencing. And then when you're actually serializing the bank parameters out, what you want to do is use the reference set to get the short ID of that reference property that you have set. And the reason why you want the short ID is, in the runtime, the way that we are going to update it through typically our set param function, which is used for both game parameter updates, or through RTPC updates through game parameters, but also through live editing when interacting from the authoring tool to your Wwise sound engine. So in most other cases, we have like just real 32, like floats that we're passing in as new parameters for the plugin processing. But for references, such as the sidechain reference here that we have for the compressor, what we pass in is that short ID for the reference, which is an ID that you can use through other Sound Engine APIs later on during processing. So get reference short ID is, I think, the bread and butter is what most people are going to use when they want to set up references to other objects in the Wwise project. We have a handful of other functions available on the reference set, which we thought would be useful. Get reference GUID that gets you the full GUID that you want for your object if you need that for any reference or for passing data around across other plugins, because the short ID might change or something like that. A couple functions to like set a reference by GUID, again, only applicable for authoring. Some simple queries on the reference, getting the name of the reference if you want to display it for some UI purposes. But that's basically it. It's like, I just want to be able to have some functionality to query what that reference is going to be for the authoring side of my plugin. In the runtime, so like I said, you turn that into a short ID, and then you have this available for later usage during your actual execution of your effect. So in this case, we turn this into the sidechain source ID, which we get down to our process sidechain mix function. And for the compressor effect, like I said, we are going to read a sidechain mix and do some processing for it. And this is a very simple view of what this looks like in the actual runtime. I'll walk you through what the code is just for clarity, but I will say the actual version of this code that you have access to in your level 2 source code, it's a little bit more complex, a little bit more robust, because there are some other conditions and edge cases to handle here. But I want to use this as an example of walking through what this should look like in your own plugin if you're developing one yourself. So first off, on your effect plugin context, you have some new functionalities such as get sidechain mix channel config, receive from sidechain mix, and send to sidechain mix. I'll show you get sidechain mix and receive from sidechain mix only in this example here. Get sidechain mix channel config. You're going to want to get this every tick because we don't have any way of getting updates on has this sidechain mix's channel config changed due to live edit in the authoring tool, or well, not changes in your primary device topology, but there's also some other things like there are some APIs to set a new channel config for your sidechain mix that is available in code. But the point is you want to query this every tick, so you're starting from scratch all the time. This is not that costly of an operation because all of the data that we're hitting inside of this function, you're going to hit again anyways when you're trying to read that sidechain mix. So this isn't much of an extra cost by just getting the sidechain mix channel config every tick. It's a little bit, but it's not that much. It's not worth sweating over, certainly. But you want to get that sidechain mix channel config to make sure everything right. Then in preparation for receiving from a sidechain mix, you want to set up your own audio buffer that includes your own temporary storage. In this case, I'm using the bookmark allocator available to plugins, so that we just have the bookmark allocator is a simple bump allocator or stack allocator if you prefer, except it uses like physical memory as opposed to thread stack memory, so you can have smaller thread stack sizes and not get stack overflows all the time because you allocated a 32 kilobyte audio buffer. But we're using the bookmark allocator here to get some temporary storage for your audio buffer, and then set that audio buffer up with the sidechain config that we got, set up with the max frames that we have for this execution, and then we receive from sidechain mix. We specify the sidechain source ID, which is the unique ID. It's a short ID of your sidechain mix. And then we also have the sidechain scope. So this scope is not just a straight like on or off, is this global or game object as our plugin UIs might suggest. This is actually an arbitrary 64-bit salt that you can add into your sidechain mix, both when sending and receiving. Again, in the stock Wwise plugins, if you have a global scope set, this scope here, this salt will be 0. If you set it to game object, we're going to query what the game object ID of the effect is, or the game object ID corresponding to this effect, and we'll use that as a salt. But theoretically, and this is quite intentional, there is not much stopping a third-party developer from saying, I want a different salt for my sidechain. I want a different scope. Maybe that's you want some mechanism of specifying an alternative game object. If you want a sidechain mix to go from one game object to another, you can do that. Or maybe you have your own internal bank of scopes that you just manually set up for your game team, for your custom plugin, where you say, oh, I have sidechain mix instance 100, 101, 102, 103, and 104, and I'm just going to pick from one of those for some certain operation. You can do that. Again, it's just an additional number that you specify when sending and receiving your sidechain mix. This will be visible in your profiler, or in the profiler. Like I showed briefly, we have a sidechain mixes table in the advanced profiler. You can preview what your sidechain scope salt is there. But this combination of source ID and salt or scope is what you use to identify, I want to get this sidechain mix and put it into this audio buffer. And then after you have that audio buffer, you can do whatever you want for it. Like here, we just meter all the channels and mix it down and just do whatever you want with it. But that is a quick whirlwind tour through what this looks like on the back end for plugin developers. Again, all the APIs that we're using for this are available to third parties. I guess the only exception that we have is the UI controls that we have for the meter, multiband meter, which meter, multiband meter, they're also using references for the game parameters now. So like those, you can set up your own metering functionality, by the way. It's not just sidechain mixes. The meter and multiband meter and compressor and Parametric EQ effect are still using custom UI controls for specifying a sidechain mix share set. But you can still use the multi-editor tool to modify those references on your plugins on your backend. Also, we have additional control coming down the pipe, which will be a full vertical property editor that you can embed straight into your plugin as well. And you can also specify the references that you want there for whatever object that you want in your that's available in your Wwise project. But that's it. Like I said, that's a whirlwind tour through what the code looks like, and also just the front end and back end functionality of the sidechain mix and all the multiband dynamics processes that we have shipping in Wwise 2025.1 later this year. And again, also available now in beta 3. Like everything that I showed here was all from the beta 3 version of the application.
Amazing. David, thanks so much for that. I'm going to give people the quick rundown on beta 3. You want to see if that camera fires back up for a hallelujah. I'm going to encourage folks to jump in on that beta 3. Head over to the installer, check out the what's new, grab it, report bugs, send us any feedback that you might have, take the survey. Stay tuned. We keep carrying the results of your feedback to you. I'm sure that the upcoming full release this fall will include some good information about what we've learned from you over this summer of beta. Thanks for joining in. And yeah, stay tuned this fall for the full release. We'll get the Wwise Expo online out there, and tune in for other Wwise Up on Air hands-ons that we have scheduled coming up. And don't forget, we got one more thing arriving to Wwise 2025.1, and that's as much as I will say about it for now. So David, if you're ready to sign off, fantastic work today, giving us an overview of what you've been up to lately.
Well, me and some other contributors at work as well. Like there's also Roman Bernard and Michael Cooper, and of course a lot of contributions that we've had from a little internal council that we have of sound designers discussing this matter as well. People have been working a lot with other professional tools and been saying like, I want this in Wwise. I mean,
Yeah,
some of the functionality has been like, hey, look at this professional tool. I just want that. Which
exactly.
actually is a pretty good guiding star, because there's some really good tools out there from people who do spend years being able to work on this problem, whereas we have not years sometimes.
Yeah. Well, and that's it, right? Is that we're out there talking with folks about what they need for their workflows and arriving here with that in 25.1 and in the future. So let us know how it's going for you out there, and we'll continue to drive towards the best workflows for interactive audio. Thanks again, David. You did great. Cool. Until next time on Wwise Up on Air, we will see you in the future. Take care, everyone.